Today, this is Bharvi Kalyani from ECEC. Today, we are going to learn about basic definitions of probability. Today, I am going to explain what is probability, uses of probability, examples of probability, random experiment and types of random experiment, sample space and classification of any sample space and classification of sample space, event and types of event. First, what is probability? Probability means guessing the outcome of an experiment, such as tossing a coin, guessing the outcome like getting heads or tails. Uses. We use probability in weather forecast, hit using in tossing a coin, rolling a die, and in predicting stocks, stock market, and etc. Examples of probability. Let us consider two examples. One tossing a coin and another one is rolling a die. Tossing a coin. The probability of getting hit. In tossing coin, we have two probabilities. One is getting heads and other is getting tails. The probability of getting heads is 1 by 2 because we are having total outcomes of the experiment are head and tail. So there are two outcomes while we want to get only one outcome. So it is 1 by 2. The probability of getting tails is equals to 1 by 2. The total probability of getting heads or tails is 1. Let us consider another example rolling it up. The possible outcomes in getting the possible outcomes in rolling a die are 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. The possible of getting one outcome from 6 outcomes is 1 by 6, whereas it is 0.168. The total probability is 1. Here, the total probability means summation of all probabilities of single events. Now, random experiment means getting more than one possible outcomes or exact outcomes, getting one possible outcome, but the outcome cannot be predicted in advance. The outcomes cannot be predicted in advance. There are three types of random variable. There are discrete random variable, continuous random variable, mixed random variable. Discrete random variable. Discrete random variable is a random variable used for finite number of values or countable number of values. Getting heads in 5 coins, getting heads while tossing 5 coins or marks obtained in a test by a student. Now let us consider continuous random variable. Continuous random variable is taken for a continuous range and it may have infinite numbers, such as height of student in a class. In that, there are examples such as if a student is 161.5 and while another student is having 165.2. It is continuous between a range from certain value to certain value. It can be used in weighting a student or amount of rainfall in a day and etc. Mixed random variable. Whereas mixed random variable is a combination of both the discrete and continuous random variable. It is based on the random variable we use it. Suppose we are using, for example, lottery with a cash price. If we have a 9 times to draw, to, if we have 9 times to use a lottery, then it can be considered as discrete. While as we do not know the value, so it is a continuous. Sample space. Sample space is a set of possible outcomes of a random experiment. Sample space means the outcomes of an experiment is called sample space and it is denoted by capital S. Sample space of tossing a coin is head or tail, while as in rolling a dice, it is 1, 2, 3, 4, 5, 6. Now we will see the classifications of sample space. There are there are two types in sample space. There is one is discrete sample space and other is continuous sample space. Discrete sample space. It is the sample space which the outcomes are countable. And in discrete, there are two types. One is finite sample space and other is discrete infinite sample space. Discrete finite sample space means the number of outcomes are finite and countable. And rolling a dice, example. Discrete infinite sample space, the outcomes are countable but infinite in number. For example, tossing a coin, getting until first head appears. Continuous sample space. The sample space that has uncountable outcomes is called continuous sample space, such as measuring the height of students in a class. Now we will discuss about event. Event is a set of possible outcomes of an experiment. It is subset of an sample space. For example, if rolling a dice is a sample space, then getting even numbers is an event. Types of event. There are nine types of events. First one is discrete event. It is defined or it is used only for discrete sample space. For example, tossing a coin and event A B getting heads. So A equals to H and it is called as a discrete event. Whereas continuous event is defined or it is used for continuous sample space. Example, temperature of a room. It can be depending on the room temperature and the weather around the room or the temperature in the room. It depends on the people in the room, which increases the carbon dioxide and which may increase in level of heat in classroom. Now, certain event means the event will completely occur is called certain event. Means, suppose if we are tossing a coin or rolling a die, suppose we'll take a rolling a die, we want to get any number from between 1 to 6. It is called certain event because we know that rolling a die, we get from the numbers from 1 to 6, which there are 1 to 6 numbers in rolling a die. So, certain event means getting the number or an event in that particular, or we know that the outcome is that, means the outcome is guaranteed to happen. Impossible event, the event that cannot occur under any conditions, means it is having no, the possibility of the event getting is zero. Suppose we are rolling a die and we want to get 7. But in dice, we have only from 1 to 6. But whereas 7, it cannot be taken or we cannot get the 7 from rolling a die. So the event of getting 7 is 0. Now, mutually exclusive event. Hmm. Mutually exclusive event means two or more events cannot occur at the same time. It's called mutually exclusive events. For example, A is getting even numbers in a die, whereas B is getting odd numbers in a die. Whereas there is no common number between A and B. So, A intersection B means intersection here represents the common element or the number between event A and event B. So, there is no common event between A and B. So, it is 0. Here, A is even numbers. Here, event numbers are 2, 4, 6, whereas B is odd numbers. There are 1, 3, 5. There is no common events between A and B. So it is 0. Equally likely events. If they have same chance or same probability of occurring. Suppose if we are rolling a die, we want to get the probability of 1. It is 1 by C. If we consider If we consider to get probability of getting 2, then it is 1 by 6. It is same for all numbers in rolling a die to get the number. So equally likely events means the numbers or events having same probability over all the experiment. Next, exhaustive event. If they together include all possible events of a sample space. Suppose if they combine all the outcomes of a sample space and it need to be equals to the total probability, such as tossing a coin, A is the event of getting heads and B is the event of getting tails. If we combine the both events, we'll get sample space, yes. While as in tossing a dice, A is event of getting odd numbers 1, 3, 5, whereas B is getting even numbers 2, 4, 6. The combination or the combining event A and B, we need to get sample space. Then combine it. Then we'll get 1, 2, 3, 4, 5, 6, which is equals to the sample space. Now, favorable outcomes. Favorable outcomes means the outcomes which are favorable for us in probability of an experiment. Suppose if I am rolling a die and I need to get less than 3 or less than 4. If it is less than 3 and I need to get the favorable outcomes for me are 1 and 2. Whereas in less than 4, we'll get 1, 3, 1, 2, 3. So the favorable outcomes means the outcomes which are favorable for us to get or win the experiment. And thank you for your valuable time. This is Bharvi Kalyani from second year ECE signing off.